In this second lab, we're also exploring the momentum principle, Newton's second law, but this time we are considering that the net force is not necessarily equal to zero. In our experiment, we used an empty plastic yogurt package in a free-fall situation. We recorded this movement using a digital camera, and we analyzed this using the tracker software. We created some models using VPython and using the base code, adjusting initial conditions, the mass of the object. In the first model, we have only the influence of the weight of gravity, and F net equals only to weight. Running this first model, we have the following results. Here, the effect of weight. We plotted the experimental position and the model, and we see that we don't have a good agreement between the experimental data and the model considering only gravity. It's also clear, observing the velocity of the experiment, that the model using only gravity is not good, because here we have a terminal velocity, final velocity, from 0.5 seconds on. To improve our modeling, we considered the drag, and in a first model we considered this model for drag, proportional only to the speed. The parameter b was adjusted by trial and error, and is here. Considering the first model for drag, we have these results using VPython. Here, the drag force. Plotting this on a graph, we see that now we have a very good agreement between our modeling considering gravity and drag and the experimental data. We also consider another model for drag using proportional to the square of the speed, and also with a constant c adjusted empirically. But it's interesting to see that the second model of drag, proportional to the square of speed, is not as good as the first model of drag. So in this lab we had a free fall condition, basically the action of gravity and drag. We observed the effect of drag. The model considering only gravity did not agree with the experiment. Considering gravity and drag proportional to the speed of the object, we had a better agreement. And in this experiment, the drag model proportional to the square of speed was not so adequate as the simpler one. Maybe because we don't have a turbulent drag. We can see that the models that use the drag can predict a final velocity. We see here that we can the final velocity near 2.7. Even when we considered that the object was thrown downwards. In the long term, the terminal velocity will be the same. Thank you.